So this is similar to some of the problems we've done before, but we want to find all of these solutions. So some of these may be imaginary, they may be real, they may be rational, they may be irrational, so it can be any type of solution, but we want to find all of them. So because this is x to the 5th power, that fundamental theorem of algebra tells us we should have 5 solutions when we finish. Okay, and once again, it doesn't matter what type of solutions, but we should have 5. So if you take a look at the graph over here, we only have 3 on the graph. So more than likely that means these are the 3 real solutions, and we're going to have 2 that are imaginary. So we're going to use that rational root theorem first to figure out possible factors. So if you remember, you take the factors of this last number here, so factors of 8 over, there's just a 1 out front here, so factors of 1. And it's positive and negative. So we have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, all over plus or minus 1. So really, positive or negative, 1, 2, 4, 8. Those are our possible factors. So we're going to use this graph to help us. So I see from the graph, so I see 1 as a possible one, and it looks like it crosses at 1 here. So we're going to use synthetic division to check. So remember, to check, we just need to make sure our remainder is going to be 0. So we're going to use our synthetic division. So if we bring down our first term and multiply, add, multiply, add, multiply, somewhere here, add, multiply, and then when we add, we see we do have 0 there. So that tells us x equals 1 is going to be one of our solutions here. Alright, then looking at my graph, I see negative 2 looks like it's 1. Okay, so we're going to check it, and we're just going to build on to our synthetic division that we already have, making sure our remainder is going to be 0. So I bring down my first term, then multiply, add, multiply, add, and it does give me 0 there. So x equals negative 2 is another solution. So remember, we're going to have 5 solutions here. We need to get this down to a quadratic, so we need to only have 3 numbers here. So then I'm going to use my graph again, and it looks like 4 here. It's going to be another one. So let's try out 4 and make sure it has a remainder of 0. And it does have a remainder of 0, so x equals 4 is another solution. So this just confirms that those solutions from the graph are solutions, and they work. So from here, we have x squared plus 0x plus 1. So we are down to a quadratic, so we are going to use the quadratic formula. So we're going to have x equals opposite of b, so that's just 0, plus or minus the square root, b squared minus 4 times a times c, all over 2a. So it's going to give us plus or minus the square root of negative 4 over 2. So remember, when you take the square root of a negative number, that gives you I. So the square root of 4 is 2, but we're going to have 2i over 2. It's going to give us plus or minus I. So remember how we said the imaginary numbers always come in pairs. So we'll see how this has plus or minus. So my other 2 answers are positive infinity, positive I, and then we have negative I. So we have 5 answers. Okay, we were supposed to have 5 answers, 5 solutions. 3 of those are real solutions. These 3 are here, and then 2 of these are my imaginary solutions, and that's why they didn't show up on the graph. Okay? So we're going to look at one more that's similar to this. So it says, if x equals 1 minus 2i is a solution of f of x, we want to find all the remaining zeros. Well, first thing, before you go any further, if you know x equals 1 minus 2i is a solution, then we also know x equals 1 plus 2i is a solution. You guys remember those always come in pairs. So we already have 2 answers. And according to this fundamental theorem of algebra, because that's to the 4th power, we should have 4 solutions. Alright, we do not have a graph or anything to go by here, so we're just going to go onto the synthetic division. Now, when you do the synthetic division, make yourself a big chart here, and you are going to need a calculator. Eventually, when we get to later in the semester, we'll do some more things with imaginary numbers, but for right now, you can use a calculator. So I'm going to put my 1 minus 2i, and if you see, I put it in parentheses here because that's what we're doing the calculator, on the ledge, because that's the solution, and then I'm going to write out my other things. Now, if you know, we are missing x cubed here, so make sure we put that 0 in. And save yourself some room. Alright. So what you're going to do is, we're going to do it just like we normally would. So I'm going to bring down my 4, and then I want to multiply 4 times 1 minus 2i. So 4 times, I'm going to always put this 1 minus 2i in parentheses. And to get to the I, it is second, and it's the period. So that should give you 4 minus 8i. And then we want to add 0 to that, so if you want to type that in, you can. So that gives us 4 minus 8i. So now I want to take that 4 minus 8i and multiply it times parentheses 1 minus 2i. Which will give us negative 12 minus 16i. And then we want to add 17 to that, which will give us 5 minus 16i. So now I'm going to multiply by parentheses 1 minus 2i, and that gives us negative 27 minus 26i. I want to add 14, and that'll give us negative 13 minus 26i. So far this looks really confusing, but just wait. So now I'm going to multiply by parentheses 1 minus 2i. Haha, that gives me negative 65 here. Well, now look, 65 plus negative 65 will give me 0. So we know we did all that right, okay? We already knew it was a solution, so it had to be 0, but it's just the work to get there. All right. So what I'm going to do now is we're going to take the 1 plus 2i, and we're going to see what happens if we use that. We should also get a remainder of 0 because we know it is a solution. Okay, so I'm going to start over here. We're going to bring down our 4. And we're going to multiply 4 times parentheses 1 plus 2i. Which gives me 4 plus 8i. So I'm going to add parentheses 4 minus 8i to this. Which gives me 8. So see how the imaginary numbers are going away. Then I'm going to take that 8 and I'm going to multiply it by 1 plus 2i. Which gives me 8 plus 16i. And I'm going to add my 5 minus 16i to that. Which gives me 13. And I'm going to multiply that times by 1 plus 2i. That gives me 13 plus 26i. So if we add that to what we already have, negative 13 minus 26i, it gives us 0. Okay? So what we did here is we already knew these were solutions. We just took them out using our synthetic division. So now, look, we have a quadratic left. And now we can use that quadratic formula. So we're going to have A is 4, B is 8, and C is 13. So we're going to have x equals negative 8 plus or minus the square roots b squared minus 4 times a times c all over 2 times a. So we're going to have negative 8 plus or minus the square root. This will give us negative 144 over 8. So the square root of 144 is 12, but we have the negative, so it's going to be negative 8 plus or minus 12i over 8. And then you can divide 8, 12, and 8 all by 4. So if we divide everything by 4, that'll be negative 2 plus or minus 3i over 2. Alright, so we were supposed to have 4 answers to this problem. We found out just from the problem itself that 1 plus n minus 2i, those were 2 of our answers. Now we just figured out using this quadratic formula that negative 2 plus or minus 3i over 2 are our other 2 answers. So we have 4 solutions. They are all imaginary, so if we were to graph this, it would never cross the x-axis. So you wouldn't even be able to use a graph to help you out here. But we have 4 solutions, and they are all imaginary.